Hi, my name is Nuranavan Chen, and I'm a product manager at VMware for Tanzu Service Mesh. Tanzu Service Mesh is a SaaS service that federates service mesh deployments in any cloud and across any cloud. The service mesh itself is based on Istio open source project, and Tanzu Service Mesh then adds a lot of additional value on top of the existing Istio open source project that enterprise customers are focused on, whether it's around security or resiliency. This is done through a construct called global namespaces, and this is what this demo will focus on. Now, global namespace is a logical grouping of services that's supposed to communicate with one another. It exists in the Tanzu Service Mesh SaaS service, which then automates all the operations that are required to get those services to communicate in a secure manner. It will also allow us to apply policies. It's a management construct where we apply policies around resiliency and security. Tanzu Service Mesh is very adequate for the enterprise customer that is focused on securing the application and providing a tightly controlled environment. Let's quickly go over the different capabilities of a global namespace and dive deeper into the demo. The first thing that will happen when you group in services from different vendors, and Tanzu Service Mesh supports any cloud. It supports VMware TKG, as well as it supports AWS EKS clusters, Azure AKS clusters, Google GKE clusters, and IBM Red Hat OpenShift clusters. Your services can run on either in a single Kubernetes cluster, multiple of those, in one site, multiple sites, and across clouds. When you group those services into those clusters, the first thing that will happen, the global namespace will automate the service discovery mechanism, which is basically automating DNS into those clusters. For example, if we have a purple service here running in TKG, VMware TKG, and we have, let's say, the blue service here running on EKS, in order for the purple service to find the blue service, someone needs to tell the purple service the IP of the AWS cluster. In AWS is going to be an ELB address. Now, when applying a domain name for a GNS, for a global namespace, the global namespace will automate the DNS records in all the clusters that requires it, so that purple can call out the blue only by the domain name, blue.prod.app.com. The IP address will be plumbed down automatically. The second thing that global namespace will take care of is the certificate management, where all services, anywhere they run, will have a trusted, unique certificate. At that point, the global namespace establishes end-to-end MTLS encryption between all the services. No matter where they run, communication will always be encrypted. The global namespace also allows us to publish an application in a highly available manner. As soon as we tell the global namespace which service is supposed to be published or exposed to the outside world, we can also supply a FQDN to connect to the application. The global namespace will automatically and dynamically configure a global load balancer. In the case of the demo here, we're going to use AVI Networks, which is NSX Advanced Load Balancer. This supports cloud bursting use cases. If you add an additional service somewhere else or expand to another cloud, the global load balancing will be automatically configured based on the policy in the global namespace. Now, the global namespace also supports advanced enterprise level policies. It supports actionable SLOs, where we can define a specific SLO's threshold around latency, CPU, or memory to a service. And if that SLO is being violated, the global namespace will make sure that that service is auto-scaled to the point where it can reduce the latency or the CPU or memory consumption. The global namespace also supports access policies, kind of microsegmentation, where we can say purple can speak with green but cannot speak with blue. Note that we're not specifying any specific cluster or site or IP, we're just defining the logic, which service is supposed to speak with which service, and the policy would apply wherever those services are. Now here we're reaching unique policies that Tanzu Service Mesh provides. The first one is around API security. since the mesh sees all the API calls that are passing through it, we can document those APIs, but we can also use this as a baseline for a policy to enforce which APIs are supposed to work across the services. So for example, if purple is supposed to do get from green with specific parameters, we can enforce that that's the only API calls that will work. If someone hijacks service purple and tries to do a put operations, or even a get but with different parameters, we can either alert or block it. This elevates the level of zero trust to new levels. We can also provide data leakage protection for data, personal identifiable information. By searching for specific patterns, such as social security numbers, credit card numbers, ABA routing numbers, and so on, we can find where such data is passing within our application. For example, perhaps purple is running credit card numbers from green. Now we can use this information to model our application, but we can also use it to enforce data leakage protection policies, so that if someone hijacks blue and tries to pull credit card from green, which is not supposed to happen, we can stop it. Note that this capability and the API visibility both work while the data is encrypted, and all communication is encrypted over the wire with no man in the middle. This is because VMware controls the mesh. So Tanzu Service Mesh can both encrypt the traffic, but also inspect the traffic right before it's encrypted, without any termination or man in the middle. Additional policies around east-west threat detection. Now, if you know WAF firewall that sits in the northbound of your network and can inspect traffic for specific application attacks, Tanzu Service Mesh does that in northbound, but also in the east-west. Across the entire mesh, we can look for OSP10 attacks, which in this demo we see a SQL injection attack being witnessed and can be controlled and stopped. There are additional policies that the global namespace supports, but that for a subsequent video. Let's look at a demo. In this demo, we have an application called Acme Sports Store, which is an open source application for testing and demoing from VMware. You can find it online. And this application is comprised of multiple microservices. We have the front-end microservice, which is called the shopping service, which I deployed in AKS, Azure Kubernetes Service, which is Azure's managed Kubernetes service. I deployed the shopping service in both US East and US West sites for highly available purposes. I also deployed the backend services, which are the catalog, the cart, its database, and there's a bunch of other services. I deployed them in AWS. This is actually TKG, which is VMware's managed Kubernetes service deployed on EC2. It really doesn't matter because Tanzu Service Mesh, as I said before, will work on any supported Kubernetes cluster. Now what we're going to do is create connectivity between all these services by establishing a service discovery domain called acme.lab. I'm going to show exactly how that works. And the connectivity is going to be established. It's going to be all MTLS encrypted end-to-end across clouds. This application will also be published through an AVI network GSLB, so NSX Advanced Load Balancer acting as a global load balancer, which will point to the to Azure site by defining shopping as the published service. So in essence, we're going to create a multi-cloud, multi-site application published through a global load balancer. Once we have the application connected and working, we're going to apply an access policy, and we're going to see how the application also corresponds to PII data leakage protection, to API security, and east-west threat detection. Let's start going into the demo. So I'm going to jump into my terminal here. And as you can see, I have different clusters, but I also have the 4 2 Azure sites and the 4 AWS sites. I'm going to jump on the AKS site, which is basically the site here on AKS East. I'm going to grab the pods, and you can see that I'm going to have the shopping service here, which is the shopping service here. Let's just, for the sake of discussion, going to go to the other Azure site. We'll see the shopping service here. And if we jump into the AWS sites, we'll see that all the services are deployed here as well. So these services are deployed in the AWS site. Now, coming back to the AKS cluster, if we inspect the deployment for the shopping service, we can see that it's already set with environment variables that define the service discovery domain that the global namespace will apply. Now, as I said, Tanzu Service Mesh is a federated Istio service, so we can connect to the cluster directly, which is this IP, which I'm gonna darken for security purposes, but I'm gonna connect to that site, and we see the application. It tells us that I'm connected directly to the Azure US East site, but then if I look at the catalog is empty, and this is because the connectivity between the services is not established yet. We need to define the service discovery domain by setting up the global namespace, and that will set up the DNS records that will allow the services to communicate over MTLS. Let's jump for 1 second also into Tanzu Service Mesh. We see that we already have the 4 clusters in Tanzu Service Mesh, and if we look at the different clusters, we can see inside the services are deployed. Now, there's a lot to see in the dashboards for Tanzu Service Mesh around performance and information that is important for understanding your application and maintaining it and operating it. But that again is for a subsequent video. We will focus on the global namespace and its policies today. And we can see the global namespace is empty, is not yet created. If I go here, we have the AVI Network Advanced Load Balancer. And if I go to GSLB, well, it's already configured into TSM, into Tanzu Service Mesh. The global load balancing is yet to be set up, and that will happen over the demo. Lastly, before we establish the connectivity, I will run a watch on getting something called service entries, which are the DNS records, and we'll see the DNS records being created when we create the global namespace. I'm going to open another tab and we can start the demo. What I have here is a YAML file that defines the global namespace. Once I logged in, I'm going to run the command Tanzu Service Mesh to apply the global namespace definition to the SaaS service. So we apply the global namespace, and it went and created the global namespace. As you can see, it already sees all the services in the 4 clusters that is part of the global namespace. We can see also in the watch that all the DNS records were created on the cluster where shopping service is. So each cluster is going to get the relevant DNS records. If we look at the DNS records here, we'll see that there are 2 endpoints that tells shopping where catalog is, for example, which are the ELB addresses for US East and US West clusters, if we look at the diagram, that we have here. So this shopping service now have a DNS record to point to the US East and US West clusters. This basically means that no developer need to know these addresses and only need to point to the logical configuration. Now lastly, in the AVI networks, we see that the global load balancer was configured, and it points to the two Azure sites. If we go into the actual domain, we see that we get connected to Azure US West, and the catalog is now being populated. And we can see that the actual products are coming from Amazon US East and US West. So we get a full mesh across the different clouds and services. Let's now look back at the Tanzu service mesh. I have a load generator generating traffic on the application. So if we're going to click into the global namespace, we'll see that a map of the connectivity between the services is being formed. In this case, we currently see connectivity coming from US West into the shopping service, and from the shopping service in US West, it goes to AWS East and West connectivity to the catalog. And as time passes, we'll see more connections being formed from both sides. This provides us not only with information about how the application is operating and some information about performance, what we called the 3 metrics. It also shows us the dependency map between the different services. We can see which services are supposed to communicate with one another. This will allow us to build better policies around microsegmentation and zero trust. At this point, we have a working global namespace. All services are communicating with one another, and everything is encrypted. Let's now start looking at the different policies. The first set of policies we want to set is access policies. Going into the inventory, we'll see that there's a section for service groups on the global namespace, which is empty. Let's create those. I have a YAML definition for that. So if I go to service groups, we can see that it defines different services like the catalog and the shopping service and order service and every service that needs to be connected. I'm going to apply that to my global namespace. And this goes and creates all the services global in the system. And the second thing is to create access control policies. For this purpose, I have a YAML file that defines access policies, and we can see that it says which service and which service are allowed to talk. Once we set up that rule, everything that's not allowed is be automatically blocked. So we're going to apply this the same way. At this point, we'll see that all the access policies are created. And there's a nice representation of that in the global namespace. If we go and click on security, we can see the green check mark that basically says that that connectivity is allowed. Anything else that's not set here is blocked. Let's see how this works. If I look at my application here, we see that we have the catalog. I'm going to refresh the page again. We see that we have the catalog here. Let's now block one of the connection. Let's block the connectivity between shopping service and the catalog. I have a YAML definition that sets to block with a deny. Well, as soon as I apply that in my global namespace, we'll see the connectivity from shopping to catalog is blocked. Now you can see that it's blocked anywhere shopping exists and anywhere catalog exists. I didn't really need to specify any IPs or sites, just the logic, which service is supposed to talk with which service. If I go to my application now, and I click refresh, we'll see the catalog is not coming up. Let's unblock ourselves by applying the allow again to change the policy back to allow. Now, this is basic connectivity security that's usually expected. We can apply that automatically across different clouds, across different sites, across different vendors, as I mentioned. But there are additional things we can do that are more advanced than that. Let's start looking at those. We see that our application is back to work. First, we want to look at where does data that we care about moves in the application. If I click on PIIs, I can see that there's 0 PIIs here. What I want to do is run a transaction and buy something in my site. Let's buy the water bottle. I'm going to add it to cart. I'm going to go to cart and I can see the water bottle here, well, a bunch of things. Click proceed to checkout. I'm going to add some information here. And I'm going to go to delivery. And this is the important part. I'm going to enter a pattern that corresponds to credit cards. And I'm going to place an order on all this merchandise. So let's jump back into Tanzu Service Mesh. Now we see the application, and if we click on PII, we see that a blue line was formed that shows us where the credit card was passed. So we see that the credit card came in from the shopping service and was passed down to the order service and down to the payment service. I click twice so I can see that coming from both ways. This allows us to model the application better and understand where the data is. Understanding where the data is also allows us to set up policies then to enforce data leakage protection. Let's look at it further. If I click into this service here, we can see the PII and we can see exactly which API calls carried PII data in them, which is the credit card number here. I can look at the API calls here. I can double click into that and I can see different analysis on the API call itself. For example, I can see the events, the source service that talks with it, the response codes, the top users, the top errors, the geos. We can also see performance information on the PII data. Performance information on API calls is super helpful when we're troubleshooting an application issue. We can understand how the API behaves, and then we can correlate that with information about the actual compute that it's running on and the network, and that will allow us to pinpoint problems better. Now, when it comes to API management, we can also go and look at the schema of the API call and drill down into the parameter level of the APIs, and we can take the API in JSON format and document it aside. Later on, I will show how we can create an API security policy that can control which API calls can happen and which can't happen on the service. Let's look at additional capabilities. So if we click on the application here and we're looking at attacks, we see that there's clear from attacks. Now we can go in and apply a threat detection policy. And I can go in and create a new policy. And this will allow us to set up OWASP 10 attacks threat detection on our services. So in this case, I'm applying this on the global namespace. I'm marking all the different attacks we're looking for. You can potentially add any custom attack, for example, log4j, by adding here the signature of that specific attack. We can control the paranoia level. If you're familiar with WAF, this is the level that enables the rules attacks. and we apply this on all the services. Now we have a rule that allows us to search for specific attacks on our global namespace. Now we can go here back to the application, the global namespace, then we can apply an attack. So let me grab here a URL that allows me to attack my application from outside. And now we ran an attack on our service. Let's look now at the global namespace. Now we see the system has detected the attack. If we hover over it, we can see that that was a SQL injection attack and a protocol violation enforcement. Let's click into it, and we can see here the API calls, and we can see exactly which API call had an attack. If we go to our security dashboard and we click on security events, we can see all the different events that happened. Anomalies around new API calls that were never detected before, and the attacks that happened as well. Now let's see how we can create a policy around API security. We can add a new policy and choose which service we're going to apply the policy on. Let's choose another service. Now we can control different aspects of the API level. We can control which PII data is allowed. For example, we can say this service is only allowed to carry credit card numbers, but it's not allowed to pass ABA routing numbers on it, nor any SSN information. Now this is important because now, and we can put the status code here, this is important because now if anyone hijacks this service and tries to pull new type of information that is not allowed, we can block it. So basically we can prevent leakage of data. The way security attacks happen is someone compromises a service and then they try to elevate themselves and pull information from other services. So this will block that type of attack. We can also control which API calls are allowed. Either we learn the API calls and create a policy and import it as OpenAPI, or we can add the APIs manually by saying /product is what allowed. And then we can save this API call. So what we've saw is that we can control different aspects of the application. We created this global namespace to create a multi-cloud application that automated the service discovery and the MTLS and certificate management. We then created security policies around access, which microsegmented our application completely, around PII data that we can control which type of data is flowing through our service mesh, WAF type capabilities around east-west threat detection, and API security that we can allow us to witness, analyze, and control the different API calls that are happening in our application. This concludes this demo. In subsequent demos, we'll show additional capabilities around application resiliency and zero trust capabilities.